Okay, so while people are still settling in or leaving, I want to welcome Godwin Yeboah, which is a research fellow at the Global Sustainable Development Research Institute at Warwick University. And we're going to stay on the topic of informal settlements, if I'm correct, but look at the data quality at different stages. So the floor is yours.
Okay, thank you very much. My presentation is about analysis of OSM data quality at different stages of a participatory mapping process, evidence from informal urban settings. And this preliminary study is being co-authored by myself, Raphael Troilo from Highgate, Vangelis and Joa also from the same institute as myself. And okay, so the logos below are the logos of our partners and other collaborators, and the one at the top right is for our main funder. So as an overview, I'm going to highlight the research questions guiding this preliminary study, and then talk about the ongoing project, and then talk about the participatory mapping process, and then how we define the mapping stages from this process. So the next will be the results from these defined mapping stages, and then give some concluding remarks. So one of the questions is, what is the level of spatial data quality one can expect at different stages of the mapping process leading to the final update of the OSM database? And also, what are the factors likely to influence quality? So these two research questions are explored using an ongoing project. So, with respect to the ongoing project, its relevance to OSM, well, I would say one thing that we are doing differently is that we are systematically adapting OSM to develop a spatially regulated sampling method in health research in a multi-country informal urban settings. This spatially regulated sampling method is not actually presented in this presentation, but I've just put a citation there. If you're interested, you can look at it later. So this ongoing project is titled National Institute for Health Research, Global Health Research Unit on Improving Health in Slums at University of Warwick. And the goals are to map health services and facilities and understand their usage across several slums in Asia and Africa. And to build on these maps to identify costs associated with seeking healthcare, and also to build economic models of health services. So across these goals, we are involving people who can change things like politicians, slum residents, and also the OSM community. And also we are collating existing evidence to inform this. The project is a 4-year project and it's costing around £6 million. And it has 5 main work packages. And the results in this presentation are drawn from the work package 1, which is mainly about the geospatial mapping of the slums. So in work package 1, we are framing our research challenge as at the intersection of spatial data quality on one hand and community engagement on the other. So we're trying to combine both. So the trade-off is the challenge, and we're trying to use a combination of methods from geospatial data science, social research to tackle this challenge. And the project partners, University of Warwick is the lead institution. In Africa, we're working with University of Ibadan. In Nigeria, in Kenya, we're working with African Population and Health Research Center. In Asia, we're working with Aga Khan University in Pakistan. And in Bangladesh, we're working with Independent University, Bangladesh. I've highlighted, there are about 7 slums we are studying, but for this presentation, I've highlighted those that I'm going to show the results. So Shasha in Nigeria, Korogocho in Kenya, and Azambasti in Pakistan. Just to give you a bit of idea about how these 3 slums look like. So this Azambasti slum, the buildings are very tall, durable, and the structures are, the rooftop architecture of the structures are of concrete type. And also they seem to be building structures in a vertical fashion on top of these structures. And this, we realized, also has implications on satellite, the image interpretation during the mapping. So this is the satellite imagery, but then we found it very difficult to interpret the building footprint. And this, I'll show animation showing this geometry change and also some graphs. In the case of Shasha in Nigeria, it's slightly different. So it's not that durable. The structures, the rooftops are like of the roof type are like roofing sheets. It's less dense and also not that tall. Yeah, let's just say that. In the case of Korogocho, is the densest of the three, and also has some similar characteristics in terms of the rooftop architecture like Shasha, but slightly different from Azambasti in that sense. So the participatory mapping process, this starts with the preparation steps where we negotiate the slum access with local partners, and also we prepare the mapping platform using hot tasking manager. We procure satellite imagery, 50 centimeter satellite imagery. We procure, and also we at this stage we do also the trainers and things like that. And also we define responsibilities amongst ourselves at University of Warwick and that of the local partners across Asia and Africa. The next step is online mapping, where we use the tasking manager to do the mapping, and then online validation, where we use JOSM to do the validation with the help of other experienced mappers. And so after that, we go to the field. We do GPS field mapping. We track the roads and the footpaths in particular, and conflict the OSM database at the GPS digitization level. And then after that, we print the field papers, go to the field. We do what we call structure geometry verification. We do this simultaneously with the other step, structure coding and field nodes. We realize that the field nodes has to be collected in a structured manner. So we combine that with the field papers using Open Data Kit and Open Map Kit. Afterwards, the data collected is conflated into the OpenStreetMap. And then beyond that, we do two key surveys, the household health survey, just to identify the structures that are inhabited and those that are not, and also the healthcare facility survey. And after that, we construct the sampling frame for the other work package, that is the household survey. So this sampling frame, once it's constructed, we use the spatially regulated sampling method I mentioned earlier to draw about 1,000 households for the survey. These are some statistics for the of the participants. What is interesting here is the case of Bangladesh, the third bar from left, where we had the presence of OSM community, and that helped also in the facilitation of the training and then also of the field work itself. These are some examples of the online mapping events involving the community in Bangladesh and then Nigeria. And these are some of the examples of the photographs of the fieldwork itself in Bangladesh and also in Kenya. So these mapping stages are drawn from the mapping process, the participatory mapping process. And we are defining the stages as first stage one being the before online mapping, the period before online mapping, and stage two being the online mapping and validation. So at this point, we've not yet gone to the field. So stage three is the actual field work, the period for the field work, and up to the point where the sampling frame or the data is sort of extracted for constructing the sampling frame. And we look at the completeness and also the modification. So modification within this period and then the completeness also at the what we've referred to as the completeness milestones. So we have this red lines there as completeness milestones, and at those points we compute we estimate the in this case in completeness the existence of features. And we found it interesting also to compute the ratio of the completeness estimate, milestone estimate at stage 3 over that of the completeness milestone estimate of stage 2. So stage 2, we have the just digitize the online, digitize the satellite imagery, digitize from the satellite imagery, and stage 3, we've done the field work and wanted to compare the two. And we are framing this as completeness differential. So just to compare and know the differences. So from this, I'm going to show you completeness graphs for these 3 satellite slum areas, and also the modification for these slum areas. So in the case of Zambasti, this is the completeness graph, the completeness differential, the ratio, or in terms of, in percentage terms, is about 82%, suggesting that actually the estimate at stage 3, that is the ground, or you can refer to as the ground truthing estimate, is, or the gap between the stage 3 and the stage 2 is about 18%. And you will see that in stage 3 also a lot of work being done in the field. So I wanted to show you actually what actually happened. Because we had a problem with the interpretation of the satellite imagery, the geometry, or should I say the map in stage 3 is slightly different from the map in stage 2. And this, how it works. So here it starts, stage 1, and stage 2 goes on, but from left to right, you see a complete change. I don't know if you noticed that, but you see a complete change. So that's the problem with the interpretation of the satellite imagery causing this change, because almost all the things digitized, features digitized, the buildings digitized, changed. In Shasha, the gap is very small. So the complex differential in percentage terms is very wide, well, very high. So in a way, it could suggest that if you complete stage 2, then it's almost okay to sort of use it for stage 3 work without necessarily going to the field. In the case of Korogocho, which is the densest of the 3, there's a wide gap, which is about 37% between stage 3 and then stage 2. We are still talking about completeness of buildings here. But then, in all of these 3, you notice that the pattern, there's one common pattern across, which is the estimate at stage 3 is always less than that of stage 2. So in a way, I'll talk about that later. In the case of the roads, the pattern is slightly different. So the estimates at stage 3 is always higher, not less, higher than stage 2. And this is the same for Shasha, even though it's higher, but then the difference is very small, but then it's still higher. And the same applies to Korogocho. Now let's look at the modifications within the stages. So we have a lot of work being done in stage 3. You see the red bars there. And the case of, just sort of confirming what happened in the animation, or what I've talked about so far. Because of the difficulty in stage 2, they had to do a lot of work in stage 3 in the field. In the case of Shasha, it's slightly different because not a lot of work in stage 3. In the case of Korogocho, appears to be a lot of work in tagging and also deleting. So in terms of factors influencing quality, the preliminary analysis so far suggests that density is key to that. Density of buildings, or in that case, I've not shown that of roads here, but density of buildings or roads seem to have influence on quality. So the denser the features, the wider the gap, or the lower the completeness differential in percentage terms. And also, the rooftop architecture appears to have influence on quality because of what I've just talked about. Well, it's linked to difficulty interpretation, which in turn actually have influence on quality. That's basically what we want to say here. And also, The results so far suggest that mapping skills, computer skills, knowledge of the tools are all factors influencing quality. So capacity building is essential for SLAM community engagement in mapping activities, especially in this context when we want to involve SLAM residents, which we consider to be local experts. So in summary, ground truthing is essential for areas with higher density of buildings and also of roads. And we found out that ground truth estimates are about 18 to 37% less than that of the online mapping estate. So I'm basically saying that ground truth estimates, that is the stage 3, is always less than that of the online mapping estate, which is stage 2. And also, the results so far points to the fact that less dense areas can reasonably, I should have put quotes there, reasonably be used as a sampling frame without necessarily going to the ground. And roads are easy to interpret, useful, and must be mapped at all stages. So this helped a lot, but then you realize that for the roads, they were going higher in stage 3, and we found out that those were, because in our context, informal urban settings, those were usually the fourth parts, which we found it a bit difficult to sort of identify in the satellite imagery, even though we did some of them, but they were all useful in a way. So for the roads, like I said earlier, in terms of the common patterns across the stage 2 and stage 3, we found that the ground estimates or stage 2 estimates, stage 3 estimates are about 11 to 248% more than the online mapping estimates. And so, yeah, in the summary, in terms of factors influencing quality, we're talking about density, rooftop architecture, mapping skills, and of course, there are likely to be more, which are not explored here. So far, I've not talked about the awesome platform, which we found useful in terms of the data extraction, the historical data that we used for this analysis. And also, the study points towards a framework for understanding spatial data quality at different mapping stages, leading to OSM update. In terms of future work or potential future opportunities, we're currently working on combining participatory mapping and automated methods, because now we have some sort of data. We've gone to the ground, we have data, we have also data at stage 2. Just using the satellite imagery, we have data on the ground, verified the data. So this is very interesting when you want to apply machine learning methods, for example. Also, there could be an opportunity for improvement of workflows and mapping tools, and also extending impact in terms of multi-level collaborations. So thank you very much for your attention.
Thank you, Godwin, for another very good talk with interesting findings. We'll take questions now. There's plenty of time. Go ahead.
Really interesting, and I would love to talk to you afterwards. I do a lot of work around workflows and field mapping for HOT, and it'd be really interesting to collaborate.
Oh, great.
The statistic, I think it was like 18 to 37% of the buildings, yeah, if you can jump to that, that would be helpful. Yeah, less than the online mapping estimates. We actually have found the same thing from Botswana to Guatemala and Liberia during field mapping activities. I would say a very similar percentage. For us, we've, which is really cool to see it validated through your work as well. For us,
is it the same like informal urban settings? Or?
Well, see, a lot of these are, there's been both urban and rural areas.
Oh, that's good. Yeah,
and I'm curious because I've always attributed it more to imagery, and I was wondering, did imagery date come into play for you guys? What was the imagery dates that you were working with? Was there a big difference?
Yes, certainly. So this was 2003, 2018, and it was, I think the gap was about 6 months. Yeah, so you're right. And even if you have the current date, even today, with our experience in Bangladesh, one of the slums there, it's unbelievable. If you go there the next week, everything has changed. Some structures demolished, others built. It's unbelievable. It's unbelievable. Yeah. But for some places like Shasha, it's almost the same. You know, irrespective of the date, it's almost the same.
Hi.
Hello.
Super cool. That was really interesting. I have a question about the buildings that you omitted after doing your field work. Did you do any like spatial statistical analysis to understand like what it was about those buildings, whether it was like aerial extent or like their orientation compared to other buildings? Like, were there any patterns that kind of came up in the structures that you did have to remove after doing the field validation?
Oh yeah, that's a very good question. Thank you. I recall going through that because I was sort of anticipating questions around those things. Some of them, if my memory serves me right, most of them, like when it comes to especially the updates at the stage 3, once they've gone to the field and they've come back with field papers and all that, and they are doing the conflation, it's always the case that there are instances where they have like 3 buildings to merge, but then how do you do that, you know? And in a way, initially they were like deleting and creating another, like just to cover the 3. And then we were trying to avoid delete, you know, as much as possible. So we try to, for example, just use one geometry of the 3 and extend it like that, and then clear the other 2 as much as possible, things like that. So, but then there could be other sort of reasons which I've not explored yet.
We have time for a few more questions. Yeah.
Thanks, Godwin, for the presentation. Just a couple of questions. So the first one is related to the previous one. So on the field, when you do the ground truth survey, you see that there are less and less buildings. Is this only due to the fact that buildings are not there, or also the fact that something was seen as a building from the satellite but was not a building, or something that was seen as, you know, more buildings attached to each other that actually was one single building? And in this case, how did you survey? Because of course you can take pictures on the ground, but it might be not so easy not to survey a building. And this is the first. The second is, I saw in your workflow that you also use Open Data Kit. Can you maybe elaborate more on why did you use it for photos or questionnaires? And thanks.
Okay, so with the last one, I'll start from the second one. So with the second one, with the Open Data Kit, we wanted to go offline. So that was the main reason. So we were trying to find solutions offline and then come back online, you know, sort of thing. And we explored other methods. And we realized that we could just sort of create tiles. After we've done the update, stage 2, we could just create tiles, load it in Open Data Kit, because it allowed us to first see what has been digitized from the satellite imagery, and then we could just place a node at the center of the structures, and later merge it. So we create nodes linking that to ODK. So we have a questionnaire. So we ask a question like, so now identify the structure, because we realized also we tried with GPS, it wasn't working in terms of identifying the structures. So, but then it helped with ODK, it helped with at least orientation. So we have the GPS sort of function that will show the data collector roughly where they're standing and things like that. And then they have to really figure out where the structure is and locate that as a response to that question. And then that would take it in. So basically it was just going offline, I would say. Yeah. Which also has implications, especially in data size, the device, and if you want to go scale it up, you know, in terms of area, because we are talking about small areas in this context. You know, I think the maximum is about 1.22 square kilometers, maximum area size in terms of, yeah. And then the other one, sorry, I forgot it. Oh, yeah. So, this is something that we are looking into, why this is the case. But so far, it's basically for the training, it's like try and identify all structures. So far as the satellite imagery suggests is a structure, of course, mapping skills and all that thing also might play a part in that. But then so far as it suggests so, then we are assuming this is the case. And we also, with extraction, because it's going to, we tagged it, so it tagged as buildings. And if it's building, then it's like, we use that as a basis to compare that with the stage 3. I don't know if I answered your question, but so certainly there are some errors around that in terms of interpretation and stuff. For example, in Azambasti, because of the rooftop, the architecture there, it was almost impossible to identify the building footprint. So we could actually, one of the recommendations would be just even, in such a situation, you don't need to even map the buildings at all. But then we found the road networks very useful. So you could just map the roads and just go to the field. This is one thing we found very interesting. There's no point to map the buildings, actually, in that industry. If you find it very difficult to interpret the satellite imagery, then there's no point at all. And that might solve this question, I think, or your worry in this question, as to, how to compare. Yeah.
Thank you for this. There's a last question, but also we're out of time, so go ahead and ask it, but people may come in and out, so go ahead.
It's really quick. Hi, I understand previously you were using printed field papers for,
yes.
Is that true? Have you stopped? If so, why?
Oh, thank you very much. We are still using it, but then we want to build on the experience we have. So first we wanted to test it. And so with this experience, we want to go further to understand. For example, one difficulty is once you've done the field papers, you've done the annotation and all that, coming back to the OSM to update is something that the mappers were like, oh, this is a lot of work, And we must find a way to sort of relieve them with this burden. At the moment, we don't know. There could be some. I know we have, is it POSM? We were trying to explore POSM, which allows you to sort of deploy digitally without necessarily printing the paper hard copy, and then deploying it on the tablet and then going there to map and then going back to the conflation to update the OSM database. We explored that and later stopped at some point because we wanted to go completely offline. Thank you. I don't know if I answered your question. Okay, thank you.
Okay, thank you, Godwin. Thank you very much. And we should move on to the next talk.